Okay, so have you gone through the last day's session? Any doubt on that session? Let me know first of all, or if you have any queries for the first day's session, like if you have any doubt, I will try to clear it out.
So up to now, no doubt, sir. We can proceed, sir.
Okay. Then we'll start from today's session. That is, we'll first of all we'll start with a the beam design, how to give the loading in a one end, and we'll fix one end. Then we will see how the beam react. We'll see the stress strain analysis. Everything we'll see. So as I have told earlier, how to choose the directory. We'll create a new model. We'll give the name. We'll change the directory. We'll select the gravity units, etc. Then we'll click OK.
இவங்க இத டோட்டல் ஸ்டேஜ் கம்பேர் பண்ணும்போது இந்த பீஸ்ஃபுல் ஸ்டேஜ்ல இருக்கிறவங்களோட growth வந்து ரொம்ப கொஞ்சம் ஸ்லோவா இருக்கும்.
Can you please mute? Sorry. Hello. Can you please mute yourself? Okay. We'll go to bodies. Then we have the flexible bodies. We'll select from create a flexible part. We'll click over here. Then it is asking for it will take me through the some steps how to draw this model, this thing. First of all, it asking for the name. We'll select a name like beam. Then it's asking for the material. So it's already chosen default material, that is steel. We can change the material, like I can right click over here, then we'll go to material, then we can go to the cases. Like within the cases we have the materials library, like cast iron, aluminum, brass, copper, etc. We can create your own material. So that we'll click on create. If we click on create, then it asking for the material name. Then we'll suppose we can give a material name. Then we can give the density. We can select what type of material is it, isotropic or orthotropic or beam or anisotropic. We can set. We can choose the Young's modulus. We can set our own Young modulus or Poisson ratio as well. In this way, we can create our own material. So for the time being, I will choose the steel as it is. I will choose the steel. Then it's asking for the beam type. What type of beam I want? That we have options like 3D beam, 2D beam, 2D beam, YZ, etc. So I will choose 3D beam. Then it's asking for the damping ratio, stiffness, that is stiffness, and damping ratio of mass will remain same. We'll go to next. Then it's asking for the the curve. If I have draw a curve, then we can select the curve so that the beam will be creating on that curve. For this, we will select line from 2 points. Like if we select 2 points, if we create 2 points, then it's possible to create the curve from this place to this place. So for this, we will create start point. Go to start point. So start point, I'll choose marker. As I have not created any marker, so I will create a marker. I'll create a marker. First marker will be marker 1 and its orientation is 0, 0, 0. I'll click on apply. So one marker has been created. Then we'll create another marker. Suppose in this direction and in 200 or say 300. and we'll give the name marker 2 and we'll click on apply. Just a second. Go to the bodies. The marker created in same direction, so I'll choose modify. Location will be 300. Okay. So the start point is, let's say the start point is marker 1, that is this one, and the end point will be marker 2. We'll go to next. Okay, we have selected the start point and the end point. Then we go to next. Then it's asking for the nodes, the distance, angle, section. Like we can create our nodes. Like if I want to put load in particular 1 point or 2 point, we can create some nodes. Like we'll insert 20 numbers of nodes. We'll choose 20 number of nodes from 0 to 1 centimeter. Distance is in a centimeter, so I'll click on insert. You can see the 20 nodes has been created, and the distance I will choose evenly distribute. If I click on evenly distribute, you can see the distance has been evenly distributed from one node to 22 node. That is from here to here. If I when I will click on finish, you can see there is 20 numbers of node within the area. Then we will go to the section. Like we have not defined the section. What will be the section of that beam? So we'll go to this one. We'll right click over here and we'll go to create. Now it's asking for the create section. Create section means the beam section. What kind of beam it will be? It could be I section beam, it could be L section, it could be like a normal S type. So we will select, you can select from over here. Select rectangular, hollow rectangular, solid circular, hollow circular, I beam, ellipse, generic beam. If you click on generic beam, okay, I will show you later. We'll go to create. We'll select a solid rectangular. Then the base height is 15 and the height is 10. It's asking for the calculate the properties from geometry. I can change the area. It's inertia like I x y in this way. We can change its inertia as well. I will choose calculate properties from geometry. Then I will click on apply. Section 1. So my section has been created. So I will do one thing. I will make the section uniform section from 1 to 22 nodes. It will be uniform. So I'll click on uniform selection. Then I will go finish. The fidelity ruler do not contain valid values. Okay. There are three objects in the database. Okay. Next. Okay, the name was like over same name was was there in my library, so that's why this name was not taking beam1. So I just renamed the name, and it's okay now. So you can see if I rotate this one, you can see a beam has been created. There is total 22 numbers of node available in that beam. If you rotate, you can see uh, I will reduce the icon size so that you can see it properly. So for the reducing the icon size, we can go to the settings, then you go to the icons. If you go to the icons, then you can create your new value and you can change the size, or you can right click over here, you can go to the appearance, you can turn off the visibility or name visibility. I will turn off the name visibility. You can see the name visibility is off. If I turn off this one, it will turn off this total visibility. So I'll make it as it is for your understanding. Okay, so if you want to create your own beam parameter, like here it is a rectangle shape. From the side view you can see it's a rectangular shape of a height of 10 millimeter and base of 15. So if you want to change this one, so what we will do, I will edit this one. Like the beam name is beam ww. So I will go to next. I will go to section. Within the section, I will right click over here and I will modify. So let's see. I will choose the generic option. When I click on the generic option, it will ask me to create my geometry. Like it's asking for the cross-sectional area. Here I have Z and Y direction, like in Z direction and Y direction. I can create my own beam size. Like if I construct the geometry with polyline, you just click over here. Then you, just a second. You click over here. Then you choose from, choose from. Okay, I have created this section. That will be my beam section. So if I select this one, you can see I have created this section. So I can apply it to my beam. My beam cross section will be this one. So I'll cancel this one. Like this one is okay. I'm okay with this beam size. And if you want to create a angle between this beam from 0 to this node, you can create your angle like from 0 to suppose say let's say 90 degree, or you choose uh, evenly rotate. So if you see from 0 to 90 degree, it's evenly rotated. So if you click finish, then you can see the beam is rotated from 0 to 90 degree evenly. Okay, it's for the design purpose. It's as your requirement. I will just showing you the procedure how to do. If you need to do anything with your beam, then you can do it and use uses of the options available over here. So I will go to the beam and I'll choose 0 0. I don't want to rotate my beam right now. I will set it as it is. I'll go to finish. Okay, Then what I have to do, I have to create the connections. Like the beam is in this area, but have not set any constraint right now. So what if I put a load over here? Then what will happen? The beam will collapse. It will go to the free fall. So what I have to do, I have to create a fixed joint over here. So I'll choose a fixed joint. Fixed joint. Pick my first body and second body. So my first body is the beam and the second body would be ground. Then I will select this area. You can see the fixed joint over here. So I'll do one thing. I will change the the grid plane. Like this is in the grid is in XY direction, but the beam is in YZ direction. So I'll choose the grid size, working grid in YZ direction. Okay. Then what I have to do, I have to apply a force. I need to apply force in my section. I will go to the forces. I will go to the create a force. I will apply force in this point, let's say beam, and in this one, and in Y direction. I will change the, you can see the load, the force is not being applied properly. So I'll go to the force, and if I modify the force, you can see the function. I will apply function that is in minus direction, minus 1000. So the force will be in this direction. I'll click on OK. Now I'll go to the simulate. First of all, I will appearance. I'll turn off the name visibility. You can uncheck it from here. This is the icon visibility, and then I go to simulate. I will simulate it for, let's say, 2 seconds, and the step size will be 0.1. So if I simulate, the frame is free falling because some issue is the constraint. Okay, let's me define the constraints again. Connections. I will delete this joint. I will go to connection. I will create a fixed joint beam with ground. We go to wireframe view, this area. Okay. Okay, now it is okay. Then I will again go to the simulation. It's again free falling. The connection, modify, fixed. Okay. So turn on simulate. Okay, let me do it again. Some error is here, so that's why it's not giving me the result, perfect result. So let's say open my database. let's open my beam model. It's already created. So if you click over here, you can see the red line indicates the force in that beam. So I'll go to the animation, close. So if I zoom out a bit, you can see the force in this area is higher. The red mark indicates the higher force over here, higher the maximum force is being applied in this point. So that's why this area is in red color. So if I go to the result tab and go to post processor, you can see the displacement over here. If I simulate again, you can see the maximum force is in 0.0 seconds at the starting point of this. So if I let's change the, let's say I can increase the forces. I can go to modify. I will increase the forces, or let's say 1000. Then again simulate this. So there will be some changes in my result, I guess. So let's stop this one, go to result tab, post processor, to this. You can see the forces already increased. So in that way you can simulate, you can create your own structure, you can simulate this one. The procedure is same, procedure is quite same. There will be some more options, and you need to discover this kind of option. If you use this software, you definitely you can understand how the thing is working. So I have a big the big model to create and to give you the result and simulate all the animation. It's kind of the piston cylinder, and I will simulate this piston cylinder. So it will take some bit of time, but let's say do one more I will give you one more example of a gear, simple spar gear. So we'll use this machinery options, Adams machinery, and we use these options to create this gear. So let's go to file, go to new database. I'll go to no. Okay. So I'll create my directory. First of all, I need to create some points. I need to create some point because I need to fix my gear in that direction. So that's why I go to the construction. First of all, I will change the grid size. Okay, let's working grid size is the spaces between the is 10 mm and 10 mm, and the size, let's say 1000. Okay, so I'll go to points. I can click over here and go to the point table. So the point table indicates where you want to put your points. There is lots of area here, I can put my points anywhere. So I'll create the chart. I will create point 1, point 2. I need 4 points. So you can see the direction is in X direction, Y direction, and Z direction. So from the coordinates, you can see it will be in Y direction, it's Z direction, and it's in X direction. So I will put my point over here. I'll choose 0, 0, 100, 0, 0, minus 100, 81, 0, 0, 100, and 81, 0, minus 100. I'll okay. So you can see 4 points has been created. This is point 1, this is point 2, this is point 4, and this is point 3. So you can see the points over here. Okay, then what I choose, I will create the cylinder. I'll create a cylinder over here and this area. So I'll choose the gear. I'll create the gear so that it can mesh properly, and if I move one gear, it definitely moves another gear. I will create a simple spark gear. So first I'll go to the cylinder, then I'll choose the radius of 1 centimeter. Go to point 1 to point 2 and another cylinder of 0.3 to 0.4. So if you change the view, you can see I have created 2 cylinders. Then I will create 2 gears on this 2 cylinder. So for this I'll go to the machinery. Within this tab in the machinery we have options like gear, belt, chain, bearing, cables, motor, cam, etc. This is under the Adams machinery system. Lots of things over there. You can discover it by yourself. You can create your model. You can see what are the changes you can make. So for the time being, I am showing me the same simple gear problem. I'll click on this create a gear pair. I'll click on this gear pair. Here is the options like what type of gear if you want. Options are spark gear, helical gear, bevel gear, worm gear, rack, hypoid, or this is available. I will choose spark gear. I'll click on next. Then it's asking for the couple. This is asking for the couples. There is option like simplified, detailed, 3D contact. I will choose the detailed option right here. The method is you can see this small instruction over here. Like if I choose the detail, it's giving the instruction like this method calculates the contact forces between the gear pair using involute function and user defined contact properties analytically, and it can calculate the contact up to 3 teeth at the same time to capture variation of loading. So if I change the method type, you can see the changes over here. You can see it. I'll go to detailed and go to next. Then it's asking for the the geometry. Here there is lots of options available, like what is the number of teeth. Like here is gear 1 and gear 2. Because I have chosen 2 gears, there will be 2 gear. So the change you can do in gear 1 and obviously in gear 2. So you can change all the properties, all the parameters, from number of teeth to the bore radius, gear width, profile. Within the profile we have options: profile, shift coefficient, addendum factor, dedendum factor, everything. So I'll make it default, let it be, and go to the next. Then it's asking for the material, like what are the material you want for your gear model. So here is also same, gear 1 and gear 2, like gear 1 and gear 2. So you can choose your material type from geometry and material type, or you can go to user input and you can give it your own mass or the value. I will choose the geometry and material type. Here is material steel has been selected. You can set the contact setting like stiffness, static friction coefficient, contact exponent, static friction transient velocity, damping coefficient, penetration, dynamic friction, transition, velocity, etc. You can choose. You can choose it for gear 1 and gear 2. I'll go to next. Now gear 1 and gear 2, I have to create the gear, so I will choose the fixed gear. What I'll do, I will to create a gear on this cylinder, and it will be fixed. The gear, I will move this part, so the gear will rotate. So I'll choose the fixed one and select body, and I'll choose part 2, and I have to do the same because gear 2 will choose the fix. I'll go to body and guess, and I'll choose the part 3. I'll go to next, and I'll click on finish. You can see I have created 2 gears over here. Then what I'll do, I will give the connections like the joints. I will make it a revolute joint over here and over here, and I will give motion to this gear, so I will see this gear will rotate. I'll choose the revolute joint. I'll select the part 2 and the ground, and this portion, you can see this sign indicates it's a revolute joint, and again another revolute joint, part 3, ground, and this point. Okay, now you have to give the motion. For giving motion, you can give a motion to the joint. So I will choose the motion. I will go to rotational joint motion. I will click this joint. Now I go to the simulation. I'll choose 2 seconds, and the step size will be 0.01. So if I click on, you can see this gear is moving, and as well as this gear is also moving. So if I extend the time a bit, I can see the animation over here. You can control your the simulation time. It is not necessary to choose the step size every time. You can change the end time, like say let's say 20 seconds, and you can change the step size as well, so to steps, and it's depending upon your needs. So I will again go to the result, post processor. Here you have to choose the window. You need to load the animation. Then here you can, if you click here, you can see the plot function is over here. You can see the plots. If I click on this, you can see the post processing. This is basically the post processing window. So as I've shown you, you can record your the animations. You can import your data from this point. You can see the where the maximum contraction is happening. You can see everything. So I'll close this model right now, and we'll do a so little bit of complex problem, a cylinder problem. Let's see. So any question till now? Any of you have any doubts? I can repeat the process. Let me know if you have any doubts till now. It's very easy. You just need to create your model, or you can import your model. Then you just put the connection properly. Then you give motions, whatever motions you want, rotational motion, translation, joint motion, what do you want, you give it properly. Then you give the forces, lots of forces is available over here. You can see applied forces, flexible connections, special forces is available. You can create your forces. Then you go to the simulation and you can simulate it, and you can see the result in post processing window. It's very easy. So I will create a new database. For this model, I need to have a 3D model. So I have created this 3D model. I have this model like name assembly simple engine mechanism, and I have uploaded my this file in the Google Drive. And if you follow the link which has been sent to you yesterday, you can see the model is available over here. And I will upload the today's session after completing the session, and you can use it for your own practices. What type of model file will be needed? I will be uploading in this folder, and I will create the folder, and you can download it from over here. I will show you. If just a second. Like I'll click on this link. This was the day one recording I have given you. You can download it. It's of 3 MB of 30 MB of file, and this is the Adams book tutorial. Lots of models files is available over here. You can see and practice by yourself. And the model file I have given in this. You can see the simple model file over here. So you can download it or practice it for your next practices. Okay. So how to import the geometry? This is another thing you are going to learn. So I will create a new model. I'll go to import. I'll go to file. I'll go to import. Then I have to select the file type. What type of file I want for to import. So in that case, I will choose the parasolid file, that is .xmt file, etc. You can choose your model as well. What file type is it is in? It could be in SolidWorks, STP, Inventor file, or IGS file, CATIA file, anything. All type of file you can import in this environment. So I'll choose parasolid over here. Then I'll go to browse. I'll select my this assembly simple engine method mechanism. I'll open. Then I have to right click over here, and I'll choose the model one. So this model one meanings where you want to import your model. Like I have created this this directory model one. So I want to put this file, this parasolid file in my model. So that's why I have to choose the model name. I'll go to OK. You can see this file imported. So if I choose this, all the part you can see, the piston head, the pin, the connecting rod cover. This is the connecting rod cover, this is the connecting rod, and this is the crank. So the model is being created in SolidWorks, but thing is, no material has been assigned, no connections has been assigned to this model, so we cannot simulate this one. So first of all, we have to create our material. We have to choose our material. So for this, I will double click on my piston head. Like I want to create material for first material, piston head. So I will go to geometry and material type, and in the material type I will choose the steel, and I'll click on OK. And the center of mass is not in the isn't piston head, so I will change the center of mass as well. So the location will be 0, 0, 0. So you can see the center of mass is in, sorry, the center, not the orientation. I need to choose the orientation. 0, 0, 0. Okay. Next, I have to choose the material for the pin. I'll go to the pin, go to modify, go to user input and geometry and material type. I'll right click over here and to still. Click on OK. To change the orientation to 270, 90 and 90. It's okay. Okay. Then I have to select the crank, and I have to input the material. Like connecting rod cover and connecting rod contains the same material, so I can do one thing. I can create a the group of material, group of this, and I can put the material in over here. So this one will be the same. So first I'll go to the crank. I will create the material. So steel, go to OK, and the center of mass 270, 70, 90, 90. Okay. Okay. So now I will create group of these two, connecting rod cover and connecting rod. So I'll go to the Boolean operation. Within the Boolean operation, I have tab merge two bodies. I'll click over here. I'll choose the first body, connecting rod cover. Let's connecting rod cover. You can right click over here. I can see what you need to select. I will choose OK, first body, and the second body is connecting rod. You can see within the connecting rod there is another solid 3. So solid 3 is basically the new group of material, a group of component which is being created with the help of connecting rod cover and this connecting rod. So I'll go to modify. I will define mass by material type. I'll choose steel. Okay, and center of mass 360. Okay, now the material has been assigned properly. So the next thing is to create. I will create do one thing. I will create a marker. Like I will choose an analysis on the connecting rod. What could be the stresses, or what could be the the loading will be applied in this connecting rod. So if you see the connecting rod, let me hide this thing. Sorry. Let's hide this one. Pin this one. Crank this one. So if you see, I will create two marker. Like in the middle of this, I want to put my load in this marker, because from the design point of view, you can see there will be a pin and the load should be in the middle of this one. So there is no point created. So I'll do one thing. I'll create a marker in this one or this one. Okay, let's go to the marker. You go to the bodies, then we go to the marker. Let's say 0, 0. Okay. Okay, let's go to the marker. I will do marker. I will add it to the part. I will go to add to part, and it's asking for the body. I will select the connecting rod and I will select the middle. Let's say this point. So if you have created the marker, this one is a marker. So if you right click over here and go to modify, you can see the location of the marker. So I will modify the location 0, 160.4 and 0. Okay, you can see the marker over here. If you see from the right side, this side, you can see the marker over here. So I will rename the marker as small end marker. Like this is the small end, this is the big end. So I will rename it as small end marker. I click on OK. If you rotate, you can see the marker is in the middle of this connecting rod. Now I have to create another marker over here. So I will go to the marker construction. Within the construction tab, I will go to marker and I will add to part. Like I need to add the marker in this part. Then I will select the connecting rod. Then I will choose the middle of the marker, middle of this one, like the middle. This one, you can see the middle of this marker. I'll click on OK, and I'll rename this one as big end marker. Click on OK, and I'll see the locations. They should be in 0, because it should be in the middle. Okay, so marker has been created. Then I have to create the joints. So for creating the joints, I will again unhide these portions, crank. Okay, so there will be a translation joint of this cylinder, this piston head, within this direction, like this y direction. So there will be a translation joint. I'll choose the translation joint. I will choose the body, piston head, and the second body will be ground. As there is no other geometries being created around this one, like the cylinder board, so I will choose the ground. If there was a cylinder board, then I will choose the cylinder board. Then I will choose the piston head, location as piston head, and I'll choose the orientation as piston head. Piston head, this one, piston head in the y direction. I'll choose OK. So from this logo, you can see there is a translation joint has been created in this portion. Now I have to create a fixed joint. The pin and the piston head will be fixed. So I'll create a fixed joint. I'll pick the first body as pin. The pin, if you right click over here, you can see pin and the piston head. If you move your mouse in this model, you can see some name is appearing. So if you right click over here, you can see what you want to select. So from this list, you can select your the main thing, like in this case I need the piston head right now, so I'll choose OK. So there is a and then it's asking for the location where you want to locate. I will choose the center mass of this pin. I'll click on OK. So now I have to create a revolute joint. This should revolve, and it should revolve with the direction, with the when it would be there will be some force, it should revolve in the direction. So I have to create a revolute joint. So before this, I will change the working grid size as in YZ direction. Then I will choose the revolute joint, like revolute joint. I will choose the first body as connecting rod, and the second body is the pin. The pin. So from the model you can see the connecting rod is fixed with the pin, and the pin should it should revolve, the connecting rod should revolve in around the pin. So that's why I'll choosing the revolute joint, and I will choose the location as the small end marker. This connecting rod small end marker I'll choose. I'll click on OK. You can see a revolute joint has been created. Now I will create another revolute joint on the crank and the connecting rod. I'll go to the revolute joint. I'll choose the first body as connecting rod. I right click over here, I can select connecting rod, and then I'll choose crank, and the location will be the big end marker. Choose OK. There will be another revolute joint with of this crank section with the ground. I will choose a revolute joint. I will choose the crank and choose a ground and choose this middle. This one. Okay. So I have created the joint. So how many joint I have created? You can see joint 5, 5 joints here over there. Joint 1 is the translation joint. Translation joint is with the piston head. Piston head is moving towards y direction, positive y to negative y. You can see there is no other model available, like there is no other parts is available, like the cylinder bore. So if there was a cylinder board, there will be the the translation joint with this cylinder head and with this cylinder board. As there is no other file is other part is available, so I will make it translation with the ground. So from our joint, there is 4 rotational joint, that is revolute joint I created in crank and with the piston, the connecting rod. There is another revolute joint with connecting rod with the pin, and the pin is fixed with the piston head, that is the fixed joint over here. Then what we'll see, uh, the motion. We'll create a motions. So for this we'll give a rotational joint motion in the crank rod. So we'll go to the motion, we'll go to the rotational joint motion, we'll select the crank rod, that is joint 5, this one. So as I have told earlier, you need to have a joint. If you need to create a motion, I'll click joint 5, and if you go to the motion, you can see one motion over here. So I'll go to modify, I'll go to the function. What I'll choose, I will do it 720 degree. Okay, and the type is not displacement. I will choose velocity. Choose OK. So if I simulate this thing, let's see how it's running for 2 seconds, and the step size is 0.01. So if I simulate this one, you can see it's, let's simulate it for 10 seconds. So you can see it's rotating. So my model is perfect. Now I can apply the forces, or I can see the load in this body. But thing you need to remember, this is now a solid body, this one. So if you need to see the the stresses and the strain, all this thing, you need to create the flexible body. So what I'll do, I will create this body a flexible body. So the model is not perfect, the model is running fine, if you give the load over here, you can see the changes, but if you need to see the stresses, I need to see the stresses on this connecting rod when the combustion engine is running and some amount of force will be acted on this cylinder head. So there will be some stresses and some deformation in this connecting rod. So for this I need to create this body as a flexible body. So I'll cut this one, then I'll go to the bodies. I'll choose within booleans operation. I will choose unite to solid, unite two solids. First one is the connecting rod, solid 1, connecting rod solid. Let's say it should have some error. Just wait. Create it. Solid 3. This one. Okay, I will hide this one first. I'll go to boolean operation. I'll go to unite to solid first body. Okay. Connecting rod solid 3 and this solid 2. So you can see this portion has been created. So it's a group basically. This is a within the boolean operation, you can see you can unite two solids and you can create a group over here. So I will do operation in this one. So I'll go to connecting rod, I'll go to make flexible, then I'll create new. Now there is a number of modes are available, up to the 6 number of modes. These are for the solid. I will choose a number modes is 10, so that is a flexible mode. Up to this number of 6, this is for rigid modes actually. Then we will choose the stress analysis and we go to the advanced settings. Within the advanced settings we have options like mesh properties. You can choose the mesh element, like here the element is solid, I will choose solid. Then we have the element shape. What kind of element shape you want to choose? There is only options available, that is the tetrahedral. And the element order you can choose linear or quadratic. You can element specification, you can choose your size of your element. If you click on size, then you can choose your size, element size. I'll choose automatic. You can create, you can edge shape, that is straight and curve or mix. I'll choose mixed now for this time. There is some more options available, like you can change the growth rate, angle per element. Lots of options available. You can check once how you can import your own mesh. Like if you have Nastran, you can import your Nastran meshes over here. uh, you can see another body name has been created, the connecting rod flexible. So this one is the flexible body. So if this body is created, you will see this body will be the will be stopped. Like if I click on OK, it will take a bit of time. So just wait for some seconds. Like it will depending upon your machine's processor, how much time it will consume. Just wait for a few seconds. So the you can see from this result tab, creating mesh preview for solid in progress. You can see the node number 1546 and the element number is 4363. This number of elements has been created, and 1546 number of nodes has been created with the help of meshing. You can see the completed, replace process successfully completed. So if the result is coming, the replace process successfully completed, then that means your model is now okay. Or if there is an error, you need to check it once. So I'll close this one and I'll go to simulation. Okay, just a second. I will unhide this portion so that it will look good. Just one. And I will hide this options. Then I'll go to simulate. I'll go to this. So you can see over here there is some amount of stresses is being applied. So if I hide this one, the piston cylinder, piston head, I will change the appearance and I will make it a little bit of transparent. Let's say 80%. So 80%. So if I make it transparent, then you can see there is a number of stresses. The red mark area indicates that the maximum amount of stresses are applied over here. So if you change it the side view and if you zoom, you can see the number of this area is the most stressed area in this model. So I can do one thing. I can let's manipulate the data and do one thing. Let's when the piston is moving, like when the in the time of the ignition, there will be some amount of force will be applying over here, like in the time of combustion. So what I'll do, I'll create a force. Let's see, let's go to the force. I'll choose a single component force. I'll select the body, piston head. The position, I'll choose the piston head center. piston head center. I choose piston head center and OK, and the direction, and I'll choose the direction will be in force is piston head. Five, and the direction will be in piston head center of mass. I will want to choose this one. Okay, I will go to the forces and I will go to the modify and I will change the function to, I will do OK. Again I have to go to the simulation. Now if you you need to select reset before running. If you check this update graphics display, so it will take bit of time. So if you have your configuration is bit of low, you can uncheck this one because you can see the animation later as well. So again I can simulate. You will see that the result is quite high. Oh, one thing I need to change again. I need the forces to be in to apply it in gradually. So I will use the step function. So I will go to the modify force. I'll go to modify. I will go to this one and I will use the step function like step time 0. At the time of 0 there will be 0, and after 0.5 second there will be, I'll choose this step function. I'll click on OK. I'll go to OK. So again I will simulate. You can see the force line over here. If I zoom in a bit, I'll go to the choose this one. You can change the color from red to any other color, like at the time of setting, uh, creating the flexible bodies, you can change the color, because red color I don't think red color is good for this model, like you cannot see view it properly, but you can see the maximum number of forces applied here. So we'll next we go to the result tab. We'll go to post processing, and before this I will do one thing. I want to show the table, like where is the maximum number of force is being applied, or what is the maximum node number, where is the maximum force level. So I'll go to the plugin, I'll go to durability, I'll go to nodal plots. Or hotspot table. I'll create a hotspot table. So basically, what hotspot table is basically, I want to see the von Mises stress in this body, and I'll choose the flexible body, that is the connecting rod, and the analysis. So I have this last run only available. You can select the analysis, which analysis you want to select, because you can do multiple type of analysis. So I'll choose this last run, and I want, yes, set 10, so that's 5, and I want 10 number of hotspot table. So I'll click on a report. So you can, from this one you can see in the node ID 1038, this is the highest amount of stress. So it should be basically in over here in this region. So from this hotspot table you can get some information. You see it's 12 Newton, 12.193 Newton per millimeter square, and this is the top 10 hotspot area, hotspot nodes I have created. You can save it, you can make it in HTML format or in TXT format, or you can import it as well. Okay, let's remember this node ID 1038. So we'll see the plot in 1038, node number 1038. Okay, let's close it. Let's go to the result tab, go to post processing. I'll go to I'll load animation. You can see the maximum deformation here over here. I can rotate it this way. So what I'll do, I will go to durability. I will select nodal plots. Like I need to see the plots on this node 1038 where the maximum stress is generated. So I'll go to the nodal plots. I will choose my body, that is my flexible body is connecting rod, and I will select the number, that is 1038, and I will click on OK. So I'll go to model, uh, angular velocity. We'll see the connecting rod, center of mass position. You can see the curve over here. There is lots of curve available within this. You can create your filter, and you can see lots of curve, lots of plots are available over here. You can choose from result set. Just like I want to see the 1038 node, so I'll choose. You can see in the node 1038 the von Mises stresses over here. So if you simulate, you can see the von Mises stress. You can choose, you can right click over here and you can choose lots of number of graphical window if you want to see. If you click over here, let's say if you want to select a node number, you want to see, you have to choose the source that is in result set, or else it will be in objects by default. You can see the force, let's say the force stational displacement is for, you can see the elements for over here. If you can see. I will make it with big size. Okay, and you can simulate or result. So some more things you can do. You can manipulate your result. You manipulate your post processing. Lots of things are available. You can already showed you how to import the animation, how to import the plottings, how to create 3D plot video file. You can create your generative report you need to create. Lots of things you can do in post processing. You try to practice it with yourself and see what are the results are coming out. And you can, I will close this one. Okay, you can change the various parameter. You can change the the material properties. You can create your material and see the changes over here. You can change the force. You can apply various types of force. So that's it for today's session. Or there is some more thing need to be learned in ADAMSCAR. So I will not start the ADAMSCAR today because it takes a lots of time. So I will make it for tomorrow's session. So I will just give you a simple introduction to ADAMSCAR for, let's say we have 10 minutes more. So I will don't save it. I will open the ADAMSCAR. Within the ADAMSCAR, we can create lots of analysis like full vehicle analysis, suspension analysis. Within the suspension, we have the front suspension, rear suspension, everything we can create lots of analysis. For this, you need to create your own model. So for the time being, I will use the Adams own, the data center data, and you can create your own subsystem. But in the Adams we have your, if you go to the C drive, and within the C drive where the Adams has been installed, you go to the MSC software. Just a second, it's a bit of laggy. Okay, you go to the Adams software, MSC software, and it could be in your program files as well. You can search it. In my system it is in C drive and in MSC software. You go to Adams. You can see in the folder like a car. Within the a car there is lots of CDB files available. That is basically the subsystem available in ADAMSCAR. So within the ADAMSCAR concept there is lots of things like the the all the parts like chassis, the spring, the tires, the body, steering subsystem, steering assembly, torque, tires, everything is available in the .tvl format. But you can import this data to create your own car model. So like I'll just give you a demo of how this works. So this is basically the ADAMSCAR. When you open up the ADAMSCAR, from this file you can create your new subsystem, suspension assembly, full vehicle assembly, and generic assembly. You can open your subsystem or assembly. I will just show you. I will open a assembly file. I will go to the shared card assembly. I will show you in next session what is subsystem, how can you create your model, how to build your model. Uh, just for this window you can see lots of things are opening like front suspension, rear suspension, steering, front tires, rear tires, brake coefficient, aero locations, crankshaft ratio. You can see this is the basically a Baha model. You can see I can change the view. I'll go to view, the render option. I will select the smooth shaded. This is basically a basic car model. You can change all these parameter, like from tires to the steering, everything you can change. You go to hard point, you go to adjust hard point, you can change everything. If you go to the table, you can see lots of things you can manipulate. If you go to the front suspension, there is lots of option available, like the front, rear, outside. These are the options available. You can manipulate with your own data. I have some my own data. I will show you with this kind of data, and you can change it. If you change the location, the uh, picture will changes. Like the model will change. In that way, it's working in that way. So some more options like assembly. I'll show you. I have a sedan car model. Let's open it. Uh, Pickup truck, sedan, discuss coupling, sedan assembly. Let's open this one. You can see from the progress window, this window, the sedan steering, sedan front tires, rear tires, brake system. This is called a subsystem. A subsystem contains the single portion of a car, and if you open an assembly, the assembly contains lots of subsystem, and within the subsystem we have these parts like from front suspension, rear suspension, brakes, this thing. So here I have a sedan car model. You too can manipulate lots of data over here. You can change. You can see it's a basically a model already provided by Adams itself. If you have your model, you can change. If you go to simulate full vehicle analysis, uh, let's say acceleration, I will choose. I'll choose next 20 and choose a road. Initial velocity 20. Start time 10. Duration steps. Gear position. Okay, click on apply. It takes a bit of time depending upon your configuration. Like I have my i5 processor, but still it's take a bit of time. I close this. If I zoom out, you can see it's a wait. You can see this to simulate. You go to animation control, and if you click, you can see the car is moving. If I zoom it a little bit, you can basically see it. Just a second. Yeah, let's you can see the car is moving, and There is lots of options. I will show you tomorrow. Lots of roads is there. Roads, the roads file, like the bump, heavy bump. You can see the skidding of your car. You can see lots of things available. You can see it. Okay, so that's all for today's session. Let me know if you have any doubt. I will upload the today's session as soon as possible. It will take a little bit of time because it need to convert the file in MP4 format. So it takes more than 30 to 35 minutes. So within the 1 hour, I will upload it as soon as possible. And you just go to the following link and download the the file.
Okay, sir.
Okay. Thank you so much.
Sir, after getting the video, okay, I will practice it
Yes.
in software, ADAM software. Then we will ask the doubts.
Okay.